Hello everybody, let's talk about integration by substitution. And probably the best way to get us started with this idea is to recall our derivative chain rule. In the derivative chain rule, we stated that if we take the derivative of a composition f of g of x, then we're going to get a derivative of f with respect to g of x times the derivative of g of x itself. Remember that we're leaving the inner function alone when we take the derivative of the outer function times the derivative of the inner function. This works well for compositions of functions. So if we're going to reverse the process right here, which is our antiderivative process, then what we're going to do is treat it as follows, saying that we are given a derivative f prime of g of x times g prime of x dx, and our antiderivative, of course, would be capital F of g of x plus c. Well, in this particular case, we can make an observation, recall that when we first defined our antiderivative, we said that capital F prime of x would be f of x. So in our case right here, we're stating that f of g of x times g prime of x dx has an antiderivative of capital F of g of x plus c. Now let's make one more substitution right here to make things a little simpler. And it goes like this. We say if we let u equal g of x and du be g prime of x, then in sort of a shortened version of all of this, we can use this formula right here that states that if we are to take the antiderivative of f of u, where u is g of x, du, which is g prime of x dx, then we're going to get f of u, antiderivative of u, plus c. Let's put this in action right here. Here's my antiderivative right here. I want to take the antiderivative, the indefinite integral of x cubed minus 1 squared times 3x squared. Well, we might note that internal to this function right here, we could state that it looks like u is the function x cubed minus 1, in which case du, our differential of x cubed minus 1, is going to be 3x squared times dx. And if we make the appropriate replacements right here, well, we do have 3x squared dx. This is du. And we do have a function of u, which is u squared. So by our antiderivative rules, of course, the power rule tells us this is going to be 1/3 of the function u raised to the third power plus a constant, our constant of integration c. So if we rewrite this one more time, this means that we actually have an antiderivative of 1/3 the quantity x cubed minus 1 to the third power plus c. And we could readily verify that if we were to take the derivative of this function, capital F of x, that would indeed be the antiderivative of this original function. Well, let's try this a couple more times right here. This is a couple other examples that we could certainly apply to this situation. You might notice right here, for example, that in the first case, in our radical down here in the denominator, we can identify a function u, which would be 4x plus 3, and we like that because its derivative du would be 4 times dx. And sure enough, we do have 4 times dx in this expression. And so it's as if we're saying, well, let's take du, the derivative of u, divided by the square root of u, which we might recognize a little bit more easily as u raised to the power negative 1/2 du. So taking an antiderivative here with respect to u, we're going to get positive 2, which is 1/1/2, right? Negative 1/2 plus 1. U raised to the positive 1/2 power plus a constant. And rewriting it to look a little bit more familiar right here, we replace u one last time and say this antiderivative should be 2 times the square root of 4x plus 3, which was u. So we've got 4x plus 3 to the 1 half plus the constant. And again, taking the derivative of this expression would certainly verify that we're going to get 4 over the square root of 4x plus 3. Well, this system also works if we're talking about trigonometric functions as well, because we can relate this to a basic kind of function right here if we state that our function u would be the quantity 3x inside of this integral, and of course the function cosine of u, if we take the derivative of u, that's going to be 3 times dx. Now, it might not be as readily apparent, but really this expression, the integral of 3 cosine of 3x dx, is equivalent to stating the cosine of the quantity 3x times, and then I'll just move the 3 in front of the dx, 3 times dx. So we really do have cosine of u times du. Well, it's antiderivative. The antiderivative of cosine is the sine of u plus a constant, and replacing u one last time because our expression was in terms of x, our antiderivative must be in terms of x. We've got the sine of the quantity 3x plus a constant. So there you go. There's some basic examples to start us out on this method of integration by substitution.